Okay, the today's work will be like this. So let us see. This is the P wave arrival, and this is the S wave arrival, right? So this is your time or your acceleration data. Okay, and this is your timing, right? So this is the time. So what I will be doing is this, that this is your P arrival time, right? So this is your P arrival time. So before the P arrival, this part is basically the background noise. So this is the background or the noise, okay, background noise. So this is your noise data. So what we will be doing, that that this is our S wave arrival. S wave arrival. So you first plot the time series and see the display, okay, and plot the acceleration versus time and see the display. And then you mark this time, right? So this is some time value T1, and this is some time value which is the T2, right? And you can take a 10-second time window. So that means this will be the T2 plus your 10 second, right? So a 10-second time window of the S wave, which we will be calling it as a signal, right? And then this is your T1 time, and you take another 10-second time window. So that means this will be the T1 minus 10 second, right? So that's a 10-second minus sign. And these are the two time windows you need to take, and this will be coming from this is starting from some zero values. So that means this is your zero, whatever is this value, that is your first sample, right? So if you can see that this is your sample index, if I call it as a sample index, so this is your zero index. So similarly, you can calculate how much is this index and how much is this index, and take those acceleration data. And similarly, you can take this index and this index. So calculate what will be this data, right? So that your acceleration values, you first take it out. And what we will be doing, we take this is your S wave window, and that S wave window, we take the data out and compute the full Fourier transform. So that means this will be now the frequency, and this will be the amplitude. We calculate the Fourier transform of this one, okay? And so you will be seeing pictures like these or this type of things. And also we will be taking this background noise and also calculate the Fourier transform of the noise, okay? And we will be plotting it simultaneously, and you will be seeing at some frequency when it has a very nice, the difference between the noise window and the this signal window. Signal means S-wave window. So this is if the signal to noise window is greater than 3 or more than 2.5, we will be saying that that is a good things. That is a good type of things. But if the frequency at which the signal is compatible to the noise, then that means that signal is submasked under the noise part. So what we need to do is basically, and that is a part of your baseline correction also, that we need to, but this is another way of baseline correction, that we remove that type of frequency from your acceleration record, then that will be enhancing the signal part, because that part which is submasked under the things, so then it will be much better when it resolved, and then your velocity and the displacement will not be skyrocketed in that sense, right? But that will be fine. That is our next day job. But today what we will be doing, we take this data window and this data window and try to plot it in a frequency versus amplitude things and see how does it looks. Okay, so start this program and see. First you plot the time series and choose the code is basically the input. So you can call in your MATLAB, there is a part, it is a G input. So it is called graphics input, and graphics input if you give 2, so that means if you bring the cursor and click it here, then this time will be noted, and click it here, then this time will be noted. And then if you know these 2 times, then one will be the data from T1 to T1 minus 10 this side, and one will be the T2 to T2 plus 10 on this side. So 10-second window you can calculate and extract it out. But first of all, you need to find out this T1 means what is the index, because your data is arranged with at 0 second. This will be some value, say 0.25. Your 0.005, this value will be say 0.31. So this is your 0 index, this is your 1 index, there is a 2 index, 3 index. So you need to find out what is this data index and this data index from this time value, and then you calculate it, right? Does it make sense to everybody? So first of all, you extract this acceleration value, then I will tell you how to take the Fourier transform and all these things.
We have to do only for one component or for all the 3 components?
The first you do for the one component accelerogram, then after, huh?
Any component notes on this, any one component.
Just take the horizontal component. Take the horizontal component, because H1 is much more enhancing the horizontal component than the vertical one, right? So take the horizontal component. So take one of the horizontal component and try to. Is it clear to everybody, right, what you need to do? Okay. No, I know. This is this part.
this model, the screw is open in internal assistant. The screw is into it. The seat the vertical component, that is, you don't see the vertical part, you should see in a Z component.
That is not an application.
The vertical one and the vertical one and each one. That will be complete. So you think
If you could go beautiful, you draw something, but anyway.
no, even if you are anything in code, just to do these action patterns and then take inside. Yesterday, things you have already learned, right? I have seen these things. It's hard.
Actually, about only three figures. That is for vertical, horizontal, and northeast, vertical, and your eastern, southeast, west, and vertical. And also you got, but this is not connected. This is
And you can also use this one, the where your data is learning, you can go here to these things. This one is good. Data is So this is doesn't have one root 2 number. Yeah. What's the time? So everything can complete two times on the so 10 second minus and 10 second plus. So we can do this so that we can. I need it right on it. So we can try to see this one. Otherwise, we connecting lambda or the not the time, the time runs on speed. So you can give a little bit. So I'm using a small time examples from my computer and try to see that. You're looking to
Sir, undo हो सकता है.
okay, come back.
Yes, sir. Control से अगर undo something.
I don't So you understand what I'm trying to say? So you are trying to calculate first time mark. Okay, with G input 2. So the 2
value you can give. Then TS start will be the whatever the time mark you give the second time. So that means first you click the P wave arrival end. So that's your first time arrival. So that is your TN end or the noise window end value. So that is your time mark 1. And then S wave window starting is the time mark of 2 because you are first clicking the P wave arrival, then you click the S wave arrival, right? So that we have done. So TS end will be the TS start plus 10, right? So it will be the 10 second, and TN start will be the TN end minus 10 second, right? So that's, you have found it out, right? So TN start and TN end, and TS start and TS end. Sorry, sorry, I take it back. Time mark one time. Oh, see, yeah. So TS end is the TS start plus this, and TN start will be the TN end minus 10, right? So that you have done. Then you need to find out the index value. So what will be the corresponding acceleration values for that? So for that, I write a index S range. So that means I am now indexing it. Okay, so which value? So that is the find. This is the T is the time. So you have read in your read file acceleration and the time. So that time is greater than equals to T start and T is less than equals to T end. So I am trying to find out the time which is greater than TS start and less than TS end, right? So similarly find the index N range, find the T greater than Tn start and T less than Tn end, right? So that means that corresponding acceleration value you find it out, right? And so the S window data is the acceleration of index S range, and S window time is the time of index S range. So that is your all for your S window. And similarly you do for the noise window. So data will be acceleration index N range, and N window will be equals to, window time will be equals to the time. So this is your time value. So this is your time value because you have read the acceleration, you have read the acceleration as a 1 or a 2 is your acceleration data. So that is your acceleration data or whatever you have read, and this is your T value. T equals to your time or that particular data colon 1. So that's your time value. That is your T value. So T and that or T or time, whatever you need to write, I don't know. So that you can put it here. So that way you can read the S wave window and this one. So now you have the data which is basically the time index and the acceleration index, right? So find out this one first.
Steve, yes, look at that. Does he hear it? The dice and click. See, then the ships and on the days. I get to get something to them. The spot up behind the chariot sick you. I took it there, it was going to you should get it. I put a chance with second. We talk here, things come steady. But the Sunday means to get us to travel to fix the police station and stay today. People like the games for then there's this with the butt. They say that you bring things on the chat and see it, you know. They do it. So I said, you know, look at the sense that's it, you know, it's, you know, here. I should receive it, but I got that is what is it with Bush? Maybe 5 years. I would have to. What? That's the answer from Mary there. But there are sausage came very I was a focus of peace. I have a discussion. Not a but shows with some people, some and listen. Your hand face off. The sausage. Also, and thank you. Young, there's and so least the ones. The protection of the world probably was in this certain seconds. You could find hiding at the switch. You say trying to grow as soon as it's in this body to give up. They see you supposed to do it. And then he develops. Go and help us. Fuck this is all men. But like, that's the things. The end. Now the way you see about CEO. I am not a stable member, so you see that today's looks like the doesn't start in the showing it. Well, it's not to end. Let's feel from to 6.5 seconds. Being able to say from what this is really. I'll advance the units. As the next one. So the standing one father is to want to on the resource and it's still make a priority this. It means good enough. This is people who want and all the explain to be. Other actual times, mentors to draw state strength that was happening in you. These are the some, this about us, in 20 so they were using stands to use that way from a mute. Your team was commenced to make a lot because I go, if me, what have been love to you? I mean, what does to the sort of covers was to just become for each of us. Skinny. And I know that now just words and even to why you say about was it a coach have what helped you do with this 20 years started something like this. You find that if I would actually be doing the travel from the needs for the wisdom. But you know, that has to be the street. I think just better in the training so that when you times when you create it up. You can tell the this team spell and you set up the enemy as an other in I am to like an automatic. But all of this and they have to play the last thing I think that is shrine. My own different you have a bit like the timing. I was saying if you find this one. I think much like I just wanted to learn because you know about and the beginning at the session and go down running on them. You don't have nobody to see us, but I've been buying it in the way. The matter is fairly short. So I haven't been but I serve behind it and I get that name. Oh, no, you just know, we just jump up both. After 2 years, help me. Still pick up some was in the day, rest. That is an artist in your way to do okay. Wake up, and slow it seems like that, but even as particular thing. Well, that's what you wait. Most things. Feel like I can. I think the bridge. Gee, they're putting out your name. This and that. You said the technology and saying all that. That one goes to saying that was there. You should listen to it. Okay, you're saying, we need back. It's a professional. That's young or down. We're talking it's working into some issues will be used. And that one is the market is shit. Then you see, yours me, well, job. So, and it was split up doing about the field comes behind this instance. And there is children and worry. Don't they? But there's no need now to please, but I should touch and touch. And in future, I think it's something we watch. See, it's a squad. Just to him, you know, like because we know this is close. Even this chin. There's too much. I'm just among the needs to device use the diminishes credit to that goes to the heart of that potential and by looking what works to certain this paper really is not. And I just my teachers fixed him to check that in working us good. The last the last day came out here, I was in what see if we took I was one but I didn't really do it like I figured my it's about it's for January until like I won the 20 weeks as of the what to the she allowed my dad see why I did this. We don't word of king money I will from with. So that's my mom's in the big so they didn't have a view like that. That was ancient like they made the way that they were on the easier. So they could move to the everything. They didn't get all their funds. Sometimes they have sickness. Yeah, that's so he ain't country. You do it I need it's a not it's in the spur back and that here in this very weapons to house. This then he says net for the fault like they threaten he at an hour. But I'm not that fortunate. Today. There he like that to the in sweet of flutter. I think. Do I think when a sharper is coming during details they took the same step. It's gone and then you can even tell over as well. Patience. Lot of rest to make sure everything on you my point is visible. So I don't to say what I'm soon will say. What I think it's what if you go to some search? Yeah. That's good. And then fashion plus doesn't this thing like such like the noise where I would now to so Russians is fine. So I'm not sure you but you to me. I think it is must be circulating that to 7 to the pizza. So like the thing that can hear at the pizza. It's named the chicken all the way to the biggest thing. Perhaps I love that they asked it. That is what the in my sustain. Yes, directly to a local. But kissing the business and answer that the answer the kind of like really to be as out who was your business, but hidden one what is keeping it but happy with the shape. She might think non but when I think just stand visions for that look just an entry thoughts and the thing points and it's a vision does check person and this means sponsor to buying was a little not being such that can inspire because of them. Really big focus and stuff for the swim. That I did search stuff. I think we'll check in that cheap. Now the mortgage is in. So I was a little like fight and scope. They do the charge, great foundation for the top. It is they don't like first. Sort of what happened to go off, it's a lot. Just the full kind thing. So we don't want to be from this. The stuff that one so that I do the illustrating was like it could discover and state this pretty words, pushing the wheels got down. You make it to build up the bone to read and eat it. That burns. Well, so what's that come? Something for the crazy. Is a lot in this thing. Okay. I think that I need coming for it. Like this to be looking from your side. You know, it should not have done a job with a female of that one over. She would go in the people. And so people like it online me never see it and just have the people over it. Okay. So it ran on the one tree. So my committee between everything by kind of sure that everyone is a good line without I don't bugs. Okay. So we're all going for you. It's to her. Sorry, can I say that because I don't know not because it's to me very fast and like but I'm one, right? The thing is you so it's beautiful. It's no worst thing. In the beautiful as well will be get out and we did she that is sad no this nothing. And it's still such as one. Everything is not similar. It's contemporary. Yes, so such a similar when you start like yeah. So that's the period when I went to seven. So you like a little bit I learned from the period, you know. And I think that is even I mean Jerry, he's cooking. I think it's a day. treat shout like basket on the thing. The dentist said, like a bubble, repeatedly, but this person, they other kids and that one man, the being studied, but I can't think. This person, that's what you're in the Texas. Everything's killing inside me. The tweaking and the shiny. But I think those uninjured don't say it. So all the time it is it's totally what's that? That's the only thing he's doing and not seeing the same thing. So that's what I was doing and is what I should do and was up in the base scary for us and that's when so yeah the feeling. This is me. I don't care. So this is how it's at numbers. So this is what that's only. And I'm not about drinking the world. I'm not saying on this. They drink with things that there's some trouble for this, you know, that's seem to go this much once I feel like I'll have yeah, well, it's a lot of teaching over there. Somebody that's the air this parent. So they you anything that is so other yeah, and we got still to know things and they can be something from further definitely and it's a bit just very like me for the 70 that is a fact to see with them more than no one is provider to be a fashion and very high level. Yeah, and then found it's hard to difference and so what they do what is you know from the foot animals and this is what I'm just the busy otherwise the first with all right so I'm just nice and not just like reflecting in some minds having the tree on the front like that is reason for the investment reason as sure I was to with this okay so that's the resident probably 0 volts even okay so what's the yes this are come to this and they will this the one ones the tower so then with this it's acting the pin drop it would be there that's what you like do you feel enterprising just power writing. So we said back, we said, then we just find a piece, equals, yeah, asking, and we keep creating, then we lips, we definitely to try on. This was said, Lord, don't have the angels, come on, go studying this year, all the main range of I make the 90 days, then I'm 2 years old. Rồi anh thấy cái như là sự cái this to me the sky from the chance we go to take picture water I remember so when I was seeing what this because teenage landed and just resume on the for the image they so other all the footage and there such we that this but sharing asking for issue there's a good people at this station there's new will be a Michael station and last you want to drive the station and you're like it's like it's on okay to an idea by about you're going to do the station that it's so non something at all other I guess okay doesn't mean statement and happen idea that I'm talking to something in person so you're asking me what about the action question the answer is asked to whatever positive that I believe is like one of the people wanted to was it was like maybe this like that but it was one very called on it back on me that it was person should not this about with acceleration about 0 from 30 and I believe it would be how we like when it's 3 bars and now and then when I had more height spoke with my house trying to check for the videos but you know we knew one part of us you know the incoming but I feel that got them next time I'm going to worry about traffic with flashing if it's on the functions yeah the answers from the viewer it is not nice but help that's good yeah okay yeah that was good. My son got dies. No, I wouldn't kick him, but I think that I was trying to tell you that I can issue that and let the coach you know it. To make killers. Yeah. Because I want to know about anger. She was just doing the thing that he did. And I actually went to target the computers. So, you know, I didn't even so that I realized and this is what I was doing. Come on, you're not going to take it. And my eyes from Butter and from Butter and Zulu. So the one when he actually has the deep, or has it, or the pattern, or the bottom, whatever the bottom of the window, right? So, because we get that, it goes as a stage, I think that comes much more. think of it to impose it and the very to my equally about and yeah, so I don't need it. Okay. So that was in hat. What is with the yeah, there's huge on the people so that the woman will not complain that investors. Okay, but the point that I think is to get. But if you pass what I'm saying is, you know, the I'm saying when you really get I speak the content, you know, some of the yes, I'm present. And it would depend with when you're paying attention to anything already in passes. You have a cut, but the matter that particular planned, and when you don't even have what to do, one either. So that is possible. Right, we can get one. What? So this idea was made like this when yeah, take this to but sit down and get it or something like that. Right? So this is another reason why I shouldn't be it. Those and so I'm able to be do it just 10 seconds. Right? So this is 10 seconds. That's all. And even what the audience should the people out there and place this thing. Very easy. You need to thing like shut and so that means just the design and where's I use I can go this with
Okay, so this is the noise window, this is the S wave or the signal window. Now, if you try to do a Fourier transform of this one, this will be basically what you have done. You have taken a, because this operation whatever you have done a 10-second time window and chop it off. So that means this is your a 10-second box when you have taken and you chop it off, right? And similarly you did it for the noise also 10-second window, you chop it off. So that means whatever you are seeing it here is basically the signal multiplied with a box function. You have just multiplied a box function and do these things. So this, if you try to take a Fourier transform, this is what we call it as a edge effect. So that will give you an edge effect into the Fourier transform. Now what is this edge effect? This is called edge effect. So this edge effect will create a spurious peak at the beginning of the Fourier transform, which is not due to this signal. This is due to this. This is your box window, right? So what we need to do is to make these things and try to multiply it with your cosine taper things. So that means we are trying to multiply it with a cosine taper. So the cosine taper means this will be straight, but this is your cos functions, right? So this is your straight, but this is your cos function. So that means the data will be tapered both the ends very nicely so that it will not produce that type of spurious peak, right? So we have to do this tapering work, right? So this is what we call it as some sort of a in the picture in the data processing. This is some sort of a window. It is called Hanning window or Hamming window, or might be the triangular window. They also have a triangular part. So that means the window will be like this, and then this will be like this. So this is your triangular window, Hamming window. So these things we need to multiply it in order to avoid the edge effect of the transform of the Fourier transform. So how to do that? So that means we first take the length of the, so that's your length of the S window. So first you find out the S window length, okay, S window length you first find it out. So that means that will be equals to the length of whatever your S data or whatever your this data, you first find it out, and then you need to multiply it with a cosine tapered window, right? So let's see the 5% cosine taper. 5% means the 5% of the entire window length. Okay, so on this side 2.5% will be the cosine tapered, 2.5% will be the cosine tapered. So that means that will be the 5% cosine tapered window. Okay, so that will be the yeah, there may be the hanging window or maybe the hemming window, whatever you like to do. I am trying to see what I have done. I think the cosine tapered will be always the 5% one. Let me check it out only on the MATLAB command values. I think you have to give the 5% or 0.05 possibly. Let me see. Is the things is working or not? So which one is working? Anything is working today? Have no. Oh, okay, that's fine. I think I am giving you some code. You just keep it in your site. Let me see. Oops. This is your what is called your okay. Okay, I had given in your folder that your the shared folder. There are two program which is called. So this is basically the this is basically the a function subprogram which you can put it into your folder, means your working directory, not the folder, in your working directory, then it will automatically take the tapering of the windows, right? So you need to just only give the data.
After the acceleration and the amplitude once is correctly done for the S-wave window analysis, then the
Yeah, you have to do the tapering, right? That's correct. So this program name is the cost tapper. So it's a cosine tapper. So you just give the tapper data. So you have the So first you find out this is the length of the data, right? So this is your length of the data which is present in your S-wave window, the length. Okay, so this is your length of the data, right? So that length of the data you need to make it so your S window tapered data. So S window tapered data, TPE tapered data. Okay, whatever you like to do, tapered data will be equals to your that program which I have sent it to you, the cosine taper. It is there, the cosine taper, and then you give your S window data, or whatever your S window data is. S window data that from your index number 1 to index number 10, that S window data, you just put it there. And similarly for noise tapered data, you just give the cosine tapered of the noise window data. Okay, so both the things you calculate first. Then I have given you another program. It is called My Fourier in the, I think this is called My Fourier, right? Or My FFT or something like that. Yeah, My FFT is there, right? You got the things in your. So My FFT. So after you do the S wave tapered data and N wave tapered data, then what I need to do is basically calculate the amplitude, right? So S amplitude spectra, right? This we have to calculate, comma, we have to also calculate the frequency, right? So it's a Fourier frequency, or the the omega values. So that will be equals to, you have give the My FFT code that has been given to you, and then you put this S tapered data, and give that things, and give your basically your delta t, right? So that means this is your delta t. You defined it first. So delta t is basically your time value number 2 minus time value number 1. So that means that is your 0.005, right? So that is your delta t. So just give these two values. One is the data, and then this is your delta t. The rest of the things the program will do. And similarly in amplitude spectra, W4, and calculate the My FFT, and then calculate the in tapered data, that means the noise data now, tapered data, delta t. So both the part you can calculate. So you calculate both the Fourier transform of both the things. Is it okay? Have you understood it or not? Any question? Huh?
So can we repeat the Fourier transform?
Yeah, so this is your My FFT. This is your S function subprogram. I had sent it to you in your shared folder, and this is also My FFT is this one. I had already calculated the tapered data from the cosine tapered subprogram you have already calculated that, you have already calculated this one. So n tapered data and s tapered data you have calculated and put that data here along with the delta t, that means the data interval, and the these things with the delta t data interval. So that will automatically calculate two things in amplitude spectra and the W4, or that means the frequency values. Any problem in any sense?
Yes. A call of that. Yes. You tell him what. Yes. But you was in your chest. What's up? Did you get the breaks that like pieces of the reason about the conclusion? The only spike are curious. I have to be less there for the down piece of this help for the source of being first moved to the other. She's into one for this the was like actually do that it can swing the card another sleeping turtles. First by those that the student to we put my question time English space seven. It's the key to the so the discussion is something or not? Should I? The discussion is something that is and so on the discussion if you find something you said is it have to if you don't discuss this yes, faster. Judging the points but yeah, I also promise the but just the this so this is the etc. Very to us is bring that they let you at this. I didn't teach us 19 something. But we are not sure. Literature comes in future.
Faster than anything
Nobody's
so made to try and what continues to target the exposure of the screening mark.
that's a big fight study. When there's these are what I think you can run pertains to this term something with apples and the fact that there is the specific that's slowly that is you were but they can discuss unless using the third person to be deal. So I still I still consider the so like now I am later what it means that this speak to my wording understand it will be this is zero from this one's a word back to your tongue was totally like it universe right so this would be out we thought and sleep yeah this indeed check so you know things that was that is it's not hospital to stuff cheap When the words ever still existed, it's been of that in way. It's called to I to over the treasure. For the as long as there is God. Fine. Three minutes. And not half. And the two will have big sense of business. If you are understanding that you do until the same as a cheap I don't think so. And then that shakes about and it really are things. The true world provided saw that animal, at the foundation, pretty much the people to full.
So what is it? Let me see here beginning on the beginning side of the story.
So yes, this is the beginning. What I have done is I have actually zoomed it and integrated.
No, are you trying to do it from the
manually? I have picked out. It from Python. I don't have MATLAB.
No, that's okay.
So manually, I have not written here, but this is velocity. In the acceleration part, I have zoomed it. Yes, this is probably yes, and I have from the data set I have picked out from here 10%. That is why it's 36 and 10 prior. And then I have chosen 39. 39 as 39. Yes, 39. 39. This peak I have chosen as the S. It is prevalent in all three. Here.
Okay.
So from here to post 10.
10 seconds.
I have.
Okay, that's
put it
fine.
out in two different DAT files. And then what I've done is this is yesterday's one. Yes, this one. And then I have just loaded that file, and this is just taken that knot, and I have done the FFT of the knot component. And I have plotted the magnitude because it's a complex number, so the real part square, imaginary part square, and square root of real part and imaginary part of the and then as I have said, I have just plotted the just the ones that are positive. Before it was coming frequency positive as well as negative. So and it is reflection of each other only. So only the positive part I have chosen, and then I have done this log plot. This I have got for the S wave, that window. And similarly, the same thing I have done for before P wave.
Before P wave,
yes.
okay.
And then I plotted both of them together. This only.
This is the only.
Yes,
yes. So it looks like to be a good thing, but
then otherwise the differentiation integration in case of distance it is, and this is the
so that is why this things is coming, because your S wave window, if you can plot the noise window, if you see the noise window, if you can see only the noise window. No, not.
This is this much I've taken noise and this much I've taken the S.
Yeah, but if you zoom this noise. No, you have shown it to me. Yeah. So these things you can see. This is a picture like this. So that means a long period is there. So that you have to remove it. So basically you have to filter out the long period wave, and so then it will be straight, because ideally it has to be straight numbers. So that has created a trouble in the long period, and that is why your distance and velocity, particularly the displacement thing, since it is also a long period thing, so that has been affected too much.
And sir, another thing,
We'll talk about this one in the next class. And that is what.
Do you mean the long period of the group velocity?
Yeah. No. Basically, the long period of the entire thing. So basically, this has a. If you see that there is this type of component, right?
That is the phase.
That is basically the noise, right? And that is a high frequency noise present. But over the high frequency noise, there's superimposed a long period. So that means if you can give me your pencil, then I can show you that we have a let's see, we have a very very long period waves, and on this long period wave, there is a superposition of the very high frequency waves, which is indeed the noise. So what we have to do, if we can remove this one, then it becomes a, this will be like this.
So is it like this long period is convolved with the short period?
Yeah, it basically superimpose on that one. So basically that we need to take it out. Okay. So the ठीक हुआ system? फिर ऑन करेंगे. इतना कम दिया इनको? इतना कम मत दिया करो.
डाटा भी है 25 और 30 ईयर का डाटा.
So इतना कम मत दिया करो. मैंने वो भी बंदा है. इतना कम देने से दिक्कत हो जाएगी. So
Sir, this pattern is showing the vertical component in
Huh?
maybe wrong. It is shown only in the vertical component. So if I do that for the vertical component only, that
yeah. Yeah.
maybe I can see something, because in the, I have taken the knot component. Knot component is almost okay.
No, you have not seen it in your naked eye, but if you plot the 10 second from here also, then you can also see that thing. Yes, that looks now good. It looks good now.
Sir, it is asking me to manually click because you had mentioned there, no? That
G input. Yeah.
So do I manually do it?
You can click it manually too,
Then
but make it a little bit zoom out the picture. Otherwise, how can you calculate? Yeah. And otherwise, how do you? Or you can go a little bit on this side, to the P arrival. Then it will be better, because you should go to the noise level than not to touch the P wave arrival things.
I mean, I should zoom it with
Yeah. Can you, yeah. So you will be something around that side. Yes. Yeah. 38 will be fine. 38.
after clicking on 30, I'm getting this, which is showing that processed K209 S window length 10 seconds.
No, this is not S window. This is the noise window.
I mean, it did not finish. I had to put another dot.
Another dot, right? So anybody successful in getting these things or not?
A little bit more time.
Hmm?
Little bit more time.
So this I will not send you the code. So now I have explained it totally. So you now need to finish it, right? So basically, I had already calculated the Fourier transform of the spectra and the S-wave spectra and these things, and then you have to take the window values from some. I told you that you make the half of the data, and half data you throw it away, and plot the S-wave window spectra, right? Because you currently need not to do anything. If you use this my FFT code, then it is almost, you have already calculated S-wave amplitude and the not wave amplitude. And what you need to do is basically the plot. If you want, I can also tell you this one, that, let me see. So everybody can do this one, right? So I need to erase something. So I try to give a I try to give a low frequency, that means whatever the frequency I need to plot. So low frequency is equals to 0.01, and the high frequency I need to go up to 10, say suppose 40 hertz. I do not like to go beyond that. Okay, so 0.01 to 40. So this is your low frequency to high frequency. So that means I am plotting my spectra with a 0.01 to the 40 range, right? So that will be sufficient to plot this spectra like this. Okay, so so therefore I make it again the index for frequency. Index for frequency will be equals to the find. Again I am finding out what, that the W4, whatever it is being calculated. So this is your frequency. Earlier FFT, there is a W4. This W4 has to be greater than or equals to low cutoff, okay, low frequency, and W4 should be less than your high frequency, right? So that you have to, I have to give it to before, so that index free is only plot up to 0.01 to this one, right? So a spectra value will be equals to, that means the S wave spectra value will be equals to the whatever your S amplitude spectra you got. Okay, so you got your S amplitude spectra from the Fourier transform. S amplitude spectra, that you got it from the Fourier transform. So that Fourier transform, it will be the index free. So that means this is your index I need to plot. Okay, so I had found out that W4, because there are a lot of frequencies, I only need the 0.01 to 40. So that I first ask you to find that which index free or index frequency contains 0.01 to 40. So that spectra value will be equals to that index, and the n spectra value will be equals to that index too. In amplitude spectra, whatever you got it from the Fourier, okay, that is your index free too, right? So I only plot 0.01 to 0.01 to 40 hertz, right? So if you did that, okay, so our frequency data, because this is your amplitude data, so our frequency data will be equals to your W4. We also make it a index free, right? So that's all our index, whatever the frequency index, I am plotting it like this way, right? So this is your frequency value, this is your N spectra, and this is your S wave spectra, right? So this part will be now plot, or you can do a log plot. So log in your MATLAB, this is a log, and then you give the frequency data as your x-axis, frequency data as the x-axis, comma the S spectra value as your y-axis, right? So similarly, you can do the hold on and make it a, say suppose, plot with your red color, and then hold on and make it a log with your frequency data, comma the N spectra value. Okay, so these two values you can plot it. Okay, and then you write down all your amplitude spectra, frequency, and all these values. You can put it down. So you understand whatever I'm trying to do. I always first define some time or some frequency and use this command in MATLAB. It's called find. Find will be finding out which frequency is greater than low frequency and which frequency is less than high frequency. So that index you will be finding out, and that index you have to calculate your amplitude spectra from the Fourier transform and these values. Make sense or not? So you can do it in the tomorrow. All these 3 station data I'd like to see.
Sir, can this part continue tomorrow?
Huh?
Like, can this part be continued?
No, this part has to be finished by today. This has to be done by today, and you can bring it tomorrow, that's fine, but has to be finished by today because I need to go to that your the stochastic simulation tomorrow. So I had to give that. So unless until you are comfortable with the Fourier spectrum, it will be very difficult to go there. So let me know if you have any question in anywhere. I can explain it. I know that everybody might be not comfortable if you have.
Sir, why only 10 seconds?
Huh?
Why?
No, it's not very. I have just give it in a random. It's not the things to be. You can give him even the 50 seconds. That's fine. But what has happened that I should the main part of the 10-second window is this, that for this is, since it is a local earthquake, so therefore what has happened, this is your after your S wave arrival, this is basically the surface wave prevails, right? So this is your S wave arrival, then there is a surface wave prevails. What I wish to do, or I try to do, is this, that I need to include on my Fourier transform calculation the maximum peak what has happened in that earthquake, so that the spectra will be represented of the maximum ground motion peak is included. So that's why I had seen that might be the 10-second will take it out, the entire S wave arrival as well as the surface waves, which basically gives them maximum peak. Okay, so that's why it's the 10-second. If you say only 5 seconds, I will take that. I can take that can explain the S wave, but that might missing the highest amplitude things, right? So that's why I have taken that 10 second. Now you said that why not 8 seconds? Yes, you can try.
Basically, what he's trying to say, his question was like, why is it only 10 seconds?
Yeah, there is no first rule. You can take it 8 seconds too. But the objective should be that it should include in that time window the highest amplitude. Yeah, so that's it should do, because we are trying to understand the spectral characteristics of the ground motion which is producing the maximum movement. So that
Then I can auto detect my S if I know that highest amplitudes need to get fitted.
right. So basically you can take whatever the highest amplitude is, and that you can find it out, right? That window from the S wave arrival will be available. Any other question? So I will be, okay, let me tell you one thing, that as I was trying to tell you in the morning that the spectral characteristics will be looks like this way, right? The amplitude spectra will looks like, if you try to get, then the amplitude spectra will be, oops, what has happened? Okay, the amplitude spectra will be looks like this way, right? Or you can have all the noises here, so amplitude spectra will be looks like this. Okay, it will be looks like this. But whenever you will try to plot these things, after you plot it, you will be seeing that this amplitude spectra what has happened? Where it is? Okay. This amplitude spectra why these things comes here? Is it this one or it is something else? Why it is not coming up? Is it a plus? Is it a, no? I like to see them. Okay, that's fine. Let me see. So the actual spectra will be looks like this way, right? The spectra will be like this if you plot it actually, but you will be seeing that in your spectra will be looks like this way, right? So that means instead of coming here, it will be a little bit up or something like that, right? This indicate that there is a baseline problem. So that indicate that low frequency side there is an issue. Okay, so the spectra is not coming like this way. The spectra starts from a very high value at the low frequency side. So that means the noise side has an issue, right? So we have to recognize that and we have to remove that. So that means that indicate that the actual character of the spectra is missing. So there may be several reasons. That the several reason means, so if you see the noise, then you might be see in the noise there is a high spike, right? So this spike gives you a very high energized wave, so that will be creating a trouble. So there are a lot of issues in the noise part, which might be, or in the signal part also there might be somewhere some spike comes in. Okay, because most of the instrument is in a building, and in that building there is always some movement, some local people might be running, or might be somebody is hammering something in the building. So that spike during the time of earthquake has also captured, right? So these are the things are quite normal, and that is why you have to do the data processing, right? And so you need to take out all those spurious signal and throw it away and process the data so that it looks like an earthquake record. So that's what we will be doing it tomorrow, that how to address the issues involving this baseline. So we will be try to recognize, and that is why I ask you to plot some of the Fourier transform and to try to see by yourself that how the different component has a different type of Fourier transform signal and how does it looks like. So then if you can see that, then it will be much more easier for us to discuss on tomorrow about what are the problems. Okay, so that problem will be identified. Huh? You have done the plot, so how does it looks like? Huh? It's not exactly the same. So this is upside down or what?
Sir, for the noise.
No. On a plot, a log plot. It's not a. It's a linear plot. So plot a log scale. Then only it will be understood. Otherwise, it will not be.
Okay, yes,
Oh.
yes.
Oh, yes. So plot always the log scale. The time is up or not? Huh? 15. 5:15. Oh, you have to always say the 2 hours. Okay, so whenever you start from that, there is a 2 hours. Okay, I understand. So, have you got it log?
No, sir, I'm doing that, sir.
So computer is with you? No?
Yes, sir.
Okay, that's good. So you can type it in your code and try to see. Huh? Integration will be denoising the data, yes. And differentiation will be adding the noises.
Suppose we have only geofont, we will get only the displacement data. Like only seismogram if we have.
Velocity data.
I mean to say that that pendulum, I don't know what is it called. I think it is called a geofont.
What? It's log scale? So how does this look like?
Sir, this is for the. This is from the noise, sir. And this is from the aspect.
No, make the two axes almost same. So
Okay, sir, so
make it
that-
a square. Make it a square. Make it a square.
Yes, so that spring mass pendulum. So from there we will get this graph.
Yes. If you have a displacement sensor, then you will be getting directly the displacement values.
So from there, if our interest is towards acceleration, then we will.
Okay, let me tell you this one, that the displacement offset, that means from the zero, the displacement offset is not a crime. because if there is a big earthquake happens, then there will be always a permanent displacement will occur, right? Permanent displacement will occur. So in that case, your displacement record will not come back to the zero. But the velocity record has to come back to the zero, okay? Because as per the Newton's laws of motion, if there is nothing, so that everything, there is no force or nothing else, then it was in a static mode, and when all the force gone, then it should return back to the static or the zero velocity. So the velocity has to be zero, but the displacement may or may not be come to zero, because if there is a big earthquake, there should be a permanent displacement as noticed.
Some ambient noise.
No, the permanent displacement, the ground is permanently displaced. Okay, so you cannot do it. Okay, so that is what I told you in San Francisco, that particularly that farmhouse gate, it has been displaced, and that displaced, it is a permanently displacement. So that is okay. So that's why we are always talking about the velocity sensor. So after I integrate, and I will be getting the velocity sensor and try to make the velocity sensor to be zero. So that thing, and then whatever I did for the velocity sensor to make it zero, I make it a differentiation again and correct the acceleration record, and then it will be zero. Okay?
And if we have accelerometer, then we directly go with the accelerometer.
Right.
Sir, I was saying that I'm still correcting that one, the acceleration plots. I hope today that will be done. And also I should be able to reach the Fourier spectra part.
But,
If there is any problem, can I ask you tomorrow? You will be.
yeah, but with the penalty on the table. With the penalty on the table, okay? So,
I'm just coming
yeah,
back in
so this is for what?
Noise.
Tapered, and this is also,
These are extra separate. This one is for the noise and this one is for the S-wave spectrum. Well, T2 plus 10 centimeters.
yeah, so this is what I am trying to say, that this comes out from this level. It should come down from the down level, right? It has to come out from here. So that should be the story, but there is the acceleration record is not totally base corrected. So the baseline correction is not, that's why it looks like this. It looks like this way. So if somebody show you that this is my Fourier spectra, you can always say, okay, your Fourier spectra has a acceleration record is not proper, right? So basically these are the interpretation you need to learn from seeing the record, seeing the spectra. You have to learn the things, right? So that how does it looks like. So it will not, and tomorrow you will see the actual things, okay? Yeah, so this you put it. This is my data. Yeah.
This is after removal of instrumental response.
No. It with the instrument present. So what has happened? So you can do. Your laptop died. Yes, that's good thing. The laptop is also time connected with their Windows, but that's okay. So you finish it tomorrow, okay? Yeah. Oh, nice. How do you get that? That's fine. Yeah. Looks to be.
That's for the north component, that's the east, and that's for the vertical component.
Yeah. So this is what the problem lies. Okay, and good. Whatever it's whether it is a actual thing or not, that I am not checking, but more or less it is. It looks like to be the pictures will be that's way. Okay.
I'm trying to plot them separately.
That's okay. Thank you very much. So you are doing it on the spider, right?
Yes.
Yeah, I also do it in spider. So It looks like to be very nice things. Okay. Okay. Thank you. Okay. Okay.
Depois, uma química. Essa nem atualizar os menus, até a expressão da desenvolvimento menus, sociedade. Você já precisa de energia, que se usa de que não é bom. Yes. Não, eu vou explicar isso. Isso é a experiência da política. Yes, sir. You know that was seen. Okay, let's see. Like this. Good. But it was not to the pure jewelry or this is the first jewelry. The first jewelry. So, to share what I think it's not going to be a that's introduced singularity, but watching. I mean, I mean, ways. Creed. Sebagai pengajar mengajar structure unit in mechanics.
So actually the degree is in specialization petroleum geosciences.
Petroleum geosciences. Okay. So when the petroleum geosciences, when did that process be